We will now look at section 2.1 and review the Cartesian coordinate system. We'll begin with some definitions. As you recall, an ordered pair, parentheses A, comma B, close parentheses, consists of two real numbers, A and B. So for example, an ordered pair, as you know, might be in the parentheses to have 5, -1. Or in a set of parentheses, we could have -3, 2. Both of those are ordered pairs and refer to a point on a graph. Our next definition is one of the Cartesian coordinate system. The definition says, the Cartesian coordinate system, also called the Cartesian plane, consists of two perpendicular real number lines, each called an axis. So two perpendicular, meaning they form right angles when they cross. Two perpendicular real number lines, each called an axis, intersecting at the 0 point of each line. The point of intersection is called the origin, and we know this, that the point where the lines cross is referred to as the origin. And the four quarters defined by the two lines are called the quadrants of the plane. So each of these sections, this is going to be quadrant 1 in the upper right. In the upper left, we'll have quadrant 2. The lower left will have quadrant 3. And in the bottom right, we'll have quadrant 4. We also know, in terms of labeling, that our x-axis is the horizontal axis, and the y-axis is our vertical axis. So we're going to begin by doing some examples where we plot points, which in most cases should be a review. Our directions say, plot the following ordered pairs on the Cartesian plane and identify which quadrant they lie in, or which axis they lie in if they don't lie inside a quadrant. So our first point, part A, asks us to graph the point 2, 3. So let's make sure that we can do that. So part A, we're going to graph the point 2, 3. So remember that we'll have an x-axis going across and a y-axis going up and down. And each of these axes have tick marks. We have positive numbers going to the right on the x-axis and negative numbers coming back to the left on the x-axis. On the y-axis, we have positive numbers going up and negative numbers coming down. Remember, the x-axis goes across and the y-axis goes up and down. Remember also that every point that you are given has an x value first and a y value second. And this tells you how to plot the point. So on the x-axis, you want to go over to the 2, which is here. And on the y-axis, you want to find the 3, which is here. And you basically need to intersect those two. So we're going to go over to the 2, we're going to go up to the 3, and we're going to place a point there where those two would intersect. And that will be the point 2, 3. Our next problem, moving to part B, part B asks us to plot the point -5, 0. So So again, we have an x value of -5 and a y value of 0. So we want to find the x value of -5 and the y value of 0, which sits at the origin, and we want to intersect those two. And so our point would lie right here. That is the point -5, 0, and that point lies on the y-axis. I'm sorry, on the x-axis. All right, let's move to part C. So part C asks us to plot the point 1, -3. So again, we have an x value of 1 and a y value of -3. For the x, we're going to find the 1 on the x-axis, and we're going to find the -3 on the y-axis. And intersecting those two, we would have a point in the fourth quadrant. Remember, the quadrants are labeled 1, 2, 3, 4. So this lies in quadrant 4. One, -3. All right, so let's look at part D now. Part D asks us to plot the point -2, 4. So our x value is -2. So we find -2 on the x-axis. Our y value is 4. So we find 4 on the y-axis, and we intersect those two, which would place the point in quadrant 2. Where I've labeled the red dot. Part E asked us to plot the point -6, -6. So I'm going to extend my axis just a little bit in both directions. And so we want to find on the x-axis the -6, and on the y-axis the -6, and we want to intersect those two, which produces a point in the third quadrant. And our last problem asks us to find the point that corresponds to 0, 5. So this is part F, 0, 5. So we find the 0 on the x-axis, which is in the middle there, and the 5 on the y-axis, and we intersect those two, which places a point on the y-axis. Once we're comfortable plotting points, the next step is to use that idea to help us sketch graphs of equations. And so that's what we're going to look at next. Our next example says sketch graphs of the following equations by plotting points. So we're going to begin with part A. Part A is asking us to graph 2x minus 5y is equal to 10. And if you recall, we graph equations typically by creating a table of values where we select values for x and plug them into the equation. We typically need 3, maybe 4 points in order to get an idea of what the graph is going to look like. So I'm just going to randomly pick some x's. I'm going to pick 0. I'm going to pick 2. I'll pick 5, and let's throw in a -1. Let's do -1. So now what we're going to do is we're going to take our equation and we're going to plug these values in. So we're going to take 2x minus 5y is equal to 10. And in place of this x, we're going to put our first value, which is 0. And we're going to work it out. 2 times 0 becomes 0, so that's going to cancel. We're left with -5y is equal to 10. We divide both sides by -5, and we get y is equal to -2. Next, we'll do it for an x value of 2. So we'll take our equation, and we'll plug a 2 in for the x. 2 times 2 is 4, minus 5y is equal to 10. We're going to subtract the 4 from both sides, which leaves me -5y is equal to 6. And divide both sides by -5. So y is equal to -6 over 5. We'll now plug in a +5 for the x. Which gives me 2 times 5 is 10, minus 5y is equal to 10. We're going to subtract 10 from both sides, leaving me -5y is equal to 0. And divide both sides by -5, and so we get a y value of 0 for that one. And the last one we're going to do, we're going to plug in a -1 for the x. So 2 times -1 is -2, minus 5y is equal to 10. We're going to add 2 to both sides, which gives me -5y is equal to 12. And then divide both sides by -5. So we have a y value of -12 over 5, or 12 over -5. Now, once that's done, then we're ready to plot our points, just like we did in the last example. So we will draw an x and y axis. We'll mark off some tick marks. I'm going to count to 5 in both directions and up and down the y-axis as well. And then we'll go in and we'll plot our points. And so the point 0, -2 will be here. The point 2, -6/5, we're going to have to estimate a little bit. That is -1.2. So just a little bit past the 1 on the negative axis. We have the point 50. And the point -1, -12/5. And again, if you want to put that in your calculator, you can see that that's equal to -2.4. So -1, -2.4. And once you can see the general shape of the graph, you can go ahead and connect those dots and draw a picture of the graph. And so this one graphs a line. All right, so let's move on and look at our next example. Part B of this problem had asked us to graph x squared plus y squared minus 6x is equal to 0. And this one's a little more involved. it may be that it would be easier to solve this equation for y before we set up our table of values, and that is always an option. So I think I am going to do that. I'm going to leave the y squared on this side. I'm going to take this x squared and move it over, and remember that you're going to move it over by subtracting the x squared from both sides. And then I'm going to take this negative 6x and move it over by adding the 6x to both sides. So now that that's done, I can go ahead and set up my table of values. And what you kind of want to keep in mind on your equation is that because it's y squared, you're going to have to consider the positive and the negative aspect of your numbers. If you were to come in here and take the square root of both sides, you would get y is equal to positive or negative x squared plus 6x. And so you have to consider as you're entering values in that the answer could be positive or negative. All right, so let's try this with a couple of values. Let's try it with 0 for the x. Let's try 3. Let's try 5, and let's maybe try 7. Okay, and again, I'm just randomly picking some numbers. We want to go and plug those numbers into our expression. So if I do it for 0, I'm going to have positive or negative, and I'll have negative 0 squared plus 6 times 0. And you can see there that the entire square root ends up zeroing out. And so the y value is equal to 0. So now we'll do it the same thing with the 3. So let's plug the 3 in for the x. So I have negative 3 squared plus 6 times 3. Now we want to be careful here with this negative 3 squared. The 3 is squared and then it is multiplied by a negative. So this is going to end up being negative 9 plus 18. Negative 9 plus 18 is 9, and the square root of 9 is 3. So our solution here is positive or negative 3. And so what that means is that when you're thinking about your coordinates, you have the coordinate 3, 3, and you have the coordinate 3, negative 3. So you have 2 coordinates coming out of that. All right, let's try the 5. That's our next x value. So negative 5 squared plus 6 times 5 underneath the square root. Again, we're going to square the 5, making 25, and then multiply by a negative. Negative 25 plus 30 gives me 5. So here we have as our solution positive or negative square root of 5. All right, again, which means that you have one point that's 5 square root of 5, and you have another point that's 5 negative square root of 5. All right, and our last one, let's do the 7. We'll plug a 7 in for the x. So again, we're going to say 7 squared is 49. We're going to tack the negative on the front. 6 times 7 is 42. So y is equal to, sorry about that, y is equal to plus or minus the square root of negative 7 All right, and we know that we really can't take the square root of a negative number, so what we've ended up doing here is choosing a value for the x that's not defined for this function. So I am just going to cross this out, and I'm going to work with the 3 that I have, and if I need to come back and add another one in just a minute, I will. All right, so let's see what we have here when we draw our graph. All right, so I'm going to go out to 4 this time on the x and y axis. And let's plot our points. So we definitely have the point 0, 0. We have the point 3, 3, which is going to be up here. And we have the point 3, negative 3, which is going to be here. We have the point 5. And the square root of 5 is approximately 2.2. All right, so I'm going to go over to the 5 and I'm going to go up 2.2. And I'm also going to go over to the 5 and go down negative 2.2. All right, so as we're looking at this graph, we want to consider what kind of shape it's making. If you're not sure yet on the shape, then you need to add a few more points to your table of values. But if you are sure on the shape, you can go ahead and start sketching this shape in. It does end up looking like a circle, something like that. All right, and our last example, they ask us to graph y is equal to x squared minus 2x. And so again, we're going to set up a table of values, placing 3 or 4 x values into the list. All right, let's try to determine some values that will be fairly easy to work with. I'm going to go with 0, 2, negative 2. Let's see if that's enough. If not, we'll add a few more. All right, so when I plug 0 into my function, you can see that it zeroes out completely. So that's an easy one. All right, let's try plugging a 2 into our function. So 2 squared minus 2 times 2. So y is equal to 4 minus 4. So y is equal to 0 there as well. All right, and then let's try the negative 2. So we have negative 2 squared minus 2 times negative 2. Negative 2 squared is 4. Negative 2 times negative 2 is a positive 4. And so y is going to equal 8. All right, so we have 3 points to work with. Let's see if that is enough for us to get an idea of what this graph is going to look like. So I know that I'm going to need to count up to 8 on the y-axis. I won't go quite so far anywhere else, maybe to 4. All right, so let's plot the points. So we have the point 0, 0, which is at the origin. We have the point 2, 0, so over to and sitting on the line. We have the point negative 2, positive 8. So over to negative 2, up to positive 8. All right, so we could plot these points. I tell you what, why don't we do one more just to make sure that we know what's happening here. I'm not exactly sure what's happening down here, so I'm going to do another point. Let's do -1. All right, so I am going to plug in -1 for the x minus 2 times -1. -1 squared is 1. -2 times -1 is a positive 2. And so y is going to equal 3. All right, and so let's plug that in as well as a point. So let's see, over -1, up 3. All right, so I can see now that this graph is coming down this way. All right, again, I'm really thinking that it probably loops around and goes back up, and I hopefully am recognizing this at this point as being the graph of a parabola. But again, at any point, if you're not sure what the graph is going to look like, you can always plot a few more points to make sure that you can see the correct picture.